Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on vapor pressure lowering. In our last lesson, we learned about preparing solutions. We discussed concentrated and diluted solutions, and we learned about the dilution process. Dilution is the procedure for preparing a less concentrated solution from a more concentrated one. We also learned how to prepare dilute solutions. In today's lesson, we will discuss the change in vapor pressure of a solvent when a certain solute is added. We will also learn how to calculate the vapor pressure of a solvent after a certain amount of solute is added. Students, you have already learned about colligative properties of a solution and about Raoult's law. Students, please define colligative properties and state Raoult's law.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had no trouble with this activity. Colligative properties are properties that depend on the number of particles or concentration of the solute in the given amount of solvent and not on their nature. Some examples include vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Raoult's law states that the partial pressure of a solvent over a solution, represented by P1, is given by the vapor pressure of the pure solvent times the mole fraction of the solvent in the solution, represented by X1. This occurs at constant temperature. The change in vapor pressure that occurs when a solute is added to a solvent is a colligative property. It is the difference between the vapor pressure of the pure solvent and the vapor pressure of a solvent in the solution. If we have a solution that only contains one solute, it can be represented by the equation x1 equals 1 minus x2. In this equation, x2 is the mole fraction of the solute. If we insert this into the Raoult's law equation, we get this. Students, let us calculate the vapor pressure of water at 90 degrees Celsius in a solution containing 5.0 grams of glucose in 100 grams of water. The vapor pressure of pure water at 90 degrees Celsius is 525.8 pascals. We also know that the mass of our solute glucose is 5.0 grams, and the mass of our solvent water is 100 grams. In order to determine the vapor pressure of water in a solution, we need first to find the mole fractions of both the solute and the solvent. We can do this by determining the number of moles of glucose and water using the equation. The mass of glucose divided by the molar mass of glucose equals 0.028 moles. The mass of water divided by the molar mass of water equals 5.56 moles. Then we can find the mole fractions of both the solute and solvent using these equations. For the solute, we divide the number of moles in the solute by the number of moles in the solute plus the number of moles in the solvent. For the solvent, we do the opposite. These numbers can be used in the Raoult's law equation. Thus, the vapor pressure of water in our solution is equal to the mole fraction of the solvent in the solution multiplied by the vapor pressure of the pure solvent. The answer is 523.17 pascals. The change in vapor pressure, or the vapor pressure lowering, is equal to the vapor pressure of the solvent minus the vapor pressure of the solvent in the solution. The answer is 2.63 pascals. The vapor pressure lowering can also be calculated using the formula. The change in vapor pressure is equal to the mole fraction of the solute in the solution multiplied by the vapor pressure of the pure solute. Students, now that we have calculated the vapor pressure of a solvent in a solution together, you are ready to do this on your own. Calculate the vapor pressure of a solution made by dissolving 218 grams of glucose in 460 milliliters of water at 30 degrees Celsius. The vapor pressure of water at 30 degrees Celsius is 31.82 torr. Also, in order to determine the number of moles of water, you will need to use its density, which we will assume is 1 gram of water per milliliter. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to solve this activity? Let us go through the steps together. First, we convert 460 milliliters of water into 460 grams of water. We can then find the number of moles for both water and glucose. We can use these numbers to determine the mole fractions of both solute and solvent, which can then be used in the Raoult's law equation. Thus, the vapor pressure of water in our solution is equal to the mole fraction of the solvent in the solution multiplied by the vapor pressure of the pure solvent. The answer is 30.4 torr. The change in vapor pressure, or the vapor pressure lowering, is equal to the vapor pressure of the solvent minus the vapor pressure of the solvent in the solution. The answer is 1.42 torr. Today, we calculated the vapor pressure of a solvent after a certain amount of solute is added. We also learned how to explain the change in vapor pressure of a solvent when a certain solute is added. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.